Okay, thank you for having me, first of all. And sorry for being so late. It was pretty hectic. My plane was delayed even before I even got to the airport. But yeah, so today I wanted to give a short peek what we do in a company I work for in Finland called Quick. So Quick is basically a mobile company founded in 2008, and we've been doing mobile development since then. And yeah, so daytime, I work as a senior system architect in our company. So my role in there involves designing and implementing infrastructures and backends for our numerous clients, and also developing tools and workflows for our developers to be more efficient, etc., on their everyday life, everyday work. And also I'm a Google Cloud developer expert and a Google authorized trainer in the Nordics. So I travel the Nordics at the night time wearing my cloud training cape and train all the companies and developers to be proficient in the Google Cloud platform. But yeah, off to today's topic. So every mobile application these days usually require some kind of a backend. It might be small, it might be large, and usually the backend requirements, they involve some kind of an authentication mechanism, authentication systems, security layers, and sometimes the backends even communicate to external services like old ERP systems, CRM systems, etc., which you definitely don't want to expose to the open world and then use by your mobile clients. So you will basically eventually we'll be building these kind of mobile API gateways, etc., to manage all that traffic, etc. And the thing about this is the solutions, the ways to build these kind of systems. There's multiple ways to come get together. And in Google Cloud Platform, the easiest, basically the simplest way to start building a scalable backend for your mobile infrastructures is to use HTTPS load balancing. So with what this does is it gives you the L7 layer of load balancing. So basically it allows you to terminate your SSL, etc., and continue from the endpoint or the load balanced endpoint back to your backend without HTTPS, so you don't have to distribute your servers all around to your VM images, etc. And you can forward the traffic from the incoming traffic to this incoming traffic to this load balancer either to your normal VM instances, like old school way, or you can forward them to your Kubernetes cluster using the container engine behind the scenes, etc. And also, there's a lot of really nice features built inside this HTTPS load balancer. In example, the CDN. It's a pretty new feature, but to enable CDN to all your traffic, you just have to enable checkbox. Couldn't really get any simpler than that. And also, like I said, the SSL termination is a really nice feature, so you don't have to distribute your security or the SSL keys to all your backend nodes, etc. Then the newest outcomer here that just went a couple weeks back came to public life. Basically, again, there was, in the early days, there was this endpoints, API endpoints kind of feature utilizing App Engine in Google Cloud Platform. But this cloud endpoints is a new interface for you to build API gateways and API endpoints. And it's basically you can do REST APIs and gRPC APIs with it. And it uses open API specification, which Google together with other companies, bigger companies, get together, this foundation started thinking about there needs to be a better way to describe your API. And then from that description to actually utilization, monitoring, authentication, all of these mechanisms. So cloud endpoints allow you to define, if you're familiar with Swagger, it's basically the open API specification is a Swagger. So you define your APIs in Swagger kind of a definition file, which states, I have this kind of routes, it takes these input arguments, it outputs this kind of a payload, which has this kind of a signature. And it requires authentication or not, this kind of specification that you tell your API specification about. And this specification also works as your documentation for your API that you can distribute, render, etc. And from that same Swagger file, you can also create like simple client solution. So you can just say that create a client for JavaScript, create a client for Python, create a client for curl from this schema definition. And what Cloud Endpoints does on top of that, it actually, when you give it that, it'll spin up you this kind of a ESP, which is an acronym for, I have to learn this, Extensible Service Proxy, which is basically Google's extended NGIX proxy. It can run as a separated service. In example, a Kubernetes container, it can run as a single pod in there. And what it does, it takes in all your traffic, incoming traffic to your APIs, those API endpoints. It knows those API endpoints, then redirects those API auth, API location, whatever API endpoints you have to your correct Kubernetes services. And also on top of that, it handles the authentication, so you don't have to. In your application logic, you don't have to do the authentication. What it also does is it handles monitoring, it handles rate limiting, all of these for you. So suddenly you have this clever layer on top of your old existing APIs that suddenly is a much more efficient, helping you out to scale, etc. And giving you insight what actually happens in your API. And as per authentication mechanism, it currently supports API keys, it supports OAuth 2 and Firebase authentication. These are like the simple authentication mechanisms that are built inside. Then other options for doing APIs for mobile is going completely serverless, or basically in Firebase case you go managed serverless in a sense. But of course with Firebase you can do a lot of things with real-time database these days, and then they have a whole suite of products for mobile development, like the remote configs, analytics, all of these, push notifications, etc. But one of more interesting things is that Cloud Functions, it's still in alpha, so I'm not in liberty to say too much about them, but they are the same way as in basically, you can imagine them the same way that in AWS there's Lambda, in Azure, I think they also have Cloud Functions or something really similar, but that's the point. You have, in a sense, you have a function that you want to deploy somewhere, and you just say, okay, deploy this function, whether it's been in JavaScript, Node, Python, whatever, and then you'll define that let's activate this function whenever this kind of a URL is called, or this happens in cloud storage, or wherever. So depending on the platform that you're using, they have these similar kind of features. But those are really powerful in a sense that you can build even complex architectures completely serverless. So on complete someone else managed systems. So let the big players take the workload of you of developing every single VM, etc. And VMs anyway these days is not so cool anymore, in my opinion. So today I wanted to do some kind of demos, etc., how we actually build these, but then because the base tool that we use to build actually our endpoints, our backends, it's going to be open source soon. It's still been brewing a couple of months. I still have to write the documentation for it, but so maybe never. But instead of concentrating on a tool that's not yet available to everybody, I wanted to go through some of the most interesting architectures, in my opinion, that I've been working on and designing. And this first one is a particularly fun case. It started as just client wanting, we need a e-commerce platform. So yeah, we are not particularly, as a company, specialized in e-commerce per se. So we partnered up with another company, the client, basically another company, with the client that was good doing these e-commerce websites. So they had their native stack that they've been working on, the platform called Magento, and it usually uses the old architecture like VMs, etc. You have clusters of machines going through. So, but in this case, what we needed is to offer the same e-commerce interface to both web and mobile clients, but there was also a twist on the mobile side, because this project actually allows us to control physical gas stations. So what this project allows us to do is that when you have this application, you can basically go to gas station and fill your car without ever leaving the car and get the receipt, and then also order a coffee to the go. So ideally, it's a beautiful project. So you have a lot of different things going on there. And as you can imagine, this kind of a project brings a lot of challenges for integrations. There's a lot of different old systems that it needs to communicate to, and different locations. Some of them are really antiquated security ruling, etc. So you have to be really careful how you build those pipelines towards these external systems, etc. And how do you actually mask that information so it doesn't ever leak out. It's because in that point you are in a control of a lot of dangerous data that, if leaked out, will be fatal to many companies. And also one key point is that every single action that happens inside this backend system needs to be traceable. It's the same principle that when you have a PCI DSS or similar kind of auditing requirements for your backend. So basically every single login system, every single access to every server needs to be logged. But also on this, every single application logic layer needed to be traceable. So whatever client clicked here, what happened till the end of that event, all these kind of things. So that brought, again, quite a few challenges how to do that efficiently. Then there's a whole different kind of a section in this project that utilizes analytics and machine learning and big data analysis for monitoring all kind of misuse, misbehavior of the system, etc. So that is something really, really fun also in this project to go through. Then the architecture for the mobile APIs, I've been designing these microservice architectures for quite a while, and this particular architecture reminded me so much about the reactive microservice architecture, which is, I'm going to get back to that later on a bit more of what it means. And then, like I said, luckily, we didn't need to audit for the PCI DSS, even though it is possible on top of Google Cloud Platform. But we have an external payment provider who actually, when users input their credit cards, we get just tokenization of that credit card, so we don't have to worry about storing that and handling that. It brings a lot of complexity in your application when you want to scale. So hopefully I could have scaled the font a little bit. But so this is the simplified architecture of that particular project. So what we basically have in Google Cloud Platform is that the first thing that the user does when all the mobile API, when it connects to the DNS API URL, it hits the Google Cloud DNS service. And then from there we decide to which of these load balancers basically we forward the traffic into. And there we have the e-commerce stack, it has, but it doesn't show, okay. On top we have the old e-commerce stack, or the old kind of architecture. So as in Magento, it isn't really ready for that much containerization yet, etc. So we had to really go forward with what we already knew from the old installation bases, etc. So we created these auto-scaling instance groups for staging and production nodes. And there's some other VM instances to run the cron jobs, because those we don't want to scale. We really want to be in control when those cron jobs are actually run, because again, the old implementation of that system isn't really reliable of handling idempotent containerization, etc. And then it had cloud cluster, and also currently we are investing in the cloud SQL. So currently the production node is running on a Percona MySQL cluster, but this is something that hopefully we will be able to switch out soon. It's still in performance testing, etc. So we just know that it's getting there. So piece by piece, I try to get rid of these self-managed services and get more of a free will and more of a free time to do other work, like meaningful work, and not just monitor the servers. And then on the mobile API side, we just use Kubernetes clusters. So we use the Google's container engine, and we run this in multi-zone environment. And I'm also going to talk all of these pieces a little bit more in a few moments. Then for that, all the microservices inside that cluster actually communicate through the BubSub service available also in the GCP. And then we use data store and Bigtable for storage. For data store, we basically we save these kind of stateful payloads inside them, as every single, in reactive microservice architecture, every single service or every single component is responsible of their own data and is responsible of their own state or being stateless. So data store is a really good match for us, especially on this case. And Bigtable, we use it to store the time series data. So whatever actions happens inside in the system, we can recall it back from the Bigtable and see what actually happened, where and when and who was the caller, etc., and trace all the things back from there. Then on GCP, what we use always is the centralized logging, which is really nice. We have centralized monitoring, tracing utility, so we know exactly on every millisecond how long time does each request take, where does that time get spent in our backend code, and whatever is this RPC call to external systems, or is it our own logic or something. So this is a really helpful tool for you to find out the bottlenecks in your application code. Then, of course, identity and access management, IAM. On these kind of level projects, you really want to have a tight schedule, who have access to where. And that IAM support in Google Cloud Platform is getting better and better all the time. They're adding more and more these roles and rules that you can use to minify the access to people. And then we have this NAT gateway service that basically is configured in the Google Cloud network. We've configured every outgoing actions to go through these kind of NAT gateways. So whenever you're accessing this kind of an old warehouse kind of connection, so the Google Cloud Network knows how to route that traffic through one of those NAT gateways, which is the only service in this whole group that has actually a public IP. And there's no incoming traffic, but only outgoing traffic. And some of those old platforms require that you do IP whitelisting and all of these kind of things, firewall rules, VPN passing. So that's why we use these NAT gateways for that. Unfortunately, there's not yet a service, NAT gateway as a service on Google Cloud Platform, but hopefully one day there is. So, like I said, it uses a popular e-commerce framework, the e-commerce site. We are not responsible of developing that. I'm just responsible of the architecture and the infrastructure, basically, holding that together and making it as simple as possible for them to do the deployments, and also about the automation of that architecture. And from the client side, high availability is a requirement. So that's why we've been looking for the Cloud SQL also to get in ease, because managing MySQL cluster isn't fun. It's not something that you enjoy doing. So definitely that is something that we are interested in, of moving that workload away from us again. But working with the instance groups, auto-scalable instance groups, is basically really simple. I'll have a short example of how we do that. And auto-scaling based on traffic. So that's, again, your HTTPS load balancer that gives you a hand in there, and your health monitoring, etc. And simple deployments, that was a requirement from us, that both the automated, so our CI knows how to deploy, and then users know how to deploy, and it should be simple, shouldn't require that much of manual tasks, etc., or having keys, etc., on your own machine. And we use the IAM for controlling the access. So, yep, this is basically just a breakdown of this, but the project breakdown, so this is one thing. We run all of this, so the e-commerce parts are running on project, let's call it X. In Google Cloud Platform, you specify project, which then in turn owns all of your resources inside that project. And basically, in a simpler sense, projects are not aware of each other unless explicitly told otherwise. So projects are your groups of your resources, your billings, etc. So we run this in project X, and I'll get back to that later on why. So how did we set this thing up? We did a custom CentOS VM image. So basically getting you start a VM in Google Cloud Platform with this CentOS. You log in, you install your necessarities, your dependencies, configure your base image as you want to, and after that, you make an image out of that. So you shut down the VM, you create an image of that disk, and then you can use that to actually spin up new instances all the time. And in Google Cloud Platform, you have this kind of image family, custom image family that you can have and take a control of these. Sorry. So the SenseOS was selected because of the good automated security updates. And also we update it regularly based on our developing day for some things that aren't automatable, or if we want to add some new features, etc., to the base image itself. Startup scripts. This is the thing that makes actually this whole thing work. I cannot enforce how really important these things are and how powerful they can be. With a extensible enough startup script, you can do pretty much anything on the VM world. So this same startup script you can also run manually after SSHing to your virtual machine, etc. So if it's done cleverly enough, it is idempotent and it can work. So it doesn't actually override what it has already done. It's basically taking sure that you're not destroying anything if you run it multiple times, etc. But yeah, I'm going to show a few peek of that. Instance metadata. This is something that is definitely, again, worth taking a look if not yet using fully. With instance metadata, it's a really powerful feature. In Google Cloud Platform, you have this concept of global metadata and instance-specific metadata. So you can have these key value pairs stored into your project that can have any meaning for you in a sense. It doesn't matter at this point what the meaning is for those. And also per instance, you can define these key value pairs and lists, etc. There's a few options that you can say to that or set the value to. But the most powerful feature comes from these when you actually fetch these things from your startup scripts. And when you define these, when you want to create an instance template, or when you actually launch your VM virtual machine image, you tell the image before it launches that, hey, by the way, you have these and these metadata values. So then your startup script can work accordingly. And then when you're doing a lot of deployments with a lot of complicated architectures, like you have this MySQL cluster, you have these instance groups of staging, production, etc. You don't want to go click through all of these all the time. So what you want to do is to use the deployment manager from Google Cloud Platform, which basically allows you to describe your whole infrastructure, all of that, in simple YAML scheme, and then include config scripts, etc., etc. And then you can just say that deployment manager, please deploy this or update this scheme, and it'll does whatever. And you can do dry runs. You can see like what actually it will do to these machines, what it would do, etc. It's really helpful whenever you are growing, if you're using this kind of VM architectures. But hopefully these days we can get more and more rid of these, but there are still systems that require these old architectures. So this is a little bit of a peek just ahead of one of our startup scripts. So in the real beginning, I fetched the environment and the role. So the environment I give to the instance template in the below, that when I create this instance template from image, I say the image family is this and this, and then I say you have your environment is production and your role is web. In this case, the role could also be cron. As we saw earlier, there was this cron images. So it uses the same base image, but when I give it the role cron, it doesn't configure all the Nginx, Magento stuff, etc. It removes all of them from that, so it's clean slate. There's no extra services, etc. running. So this is just one really quick and easy way to build powerful startup scripts. So then the more important thing, or the more interesting thing, in my opinion, is the mobile infrastructure. So like I said, we use the Kubernetes cluster running on Google Container Engine, so we don't have to manage the master node, and multi-zone for higher availability. I'm not going to say high availability, but still, it's a really rare that two zones, I think never happened, but two zones basically going down at the same time. But still you have some things that you need to take care of when you are running in multi-zone, etc. Because your pod, if your pod is just running on a singular node, so you're not replicating it, then it goes away if the zone might go away. until the replication controller can actually find a new place, new home for it. And this is the project that it's based on. Hopefully someday it'll have a proper name and it's actually being open sourced. But this Q project framework, it started, as I said, I also built tools for developers to ease our development work. So it is really as unopinionated as possible. So it doesn't get into your way as a developer. It is currently for Node.js, our Node.js backend projects. And what it does, it's basically wrapping the Express.js. It's utilizing the Express.js. So if you know Express.js, you can build on top of this. But this also takes away all the complexities of microservice architectures, Kubernetes deployments, service discovery, etc. So without even you thinking of deploying and all of this, where it goes, how this service is going to find that one, or this is actually a service and that is another service. This one masks all that away. I can at some point show to interest parties of how it works a little bit, but as this is also not my own machine, so I cannot really go do the live coding right now. But yeah, that is something that really simplifies our development work, and our developers are more free to just express their logic needs, just write the code and don't care about the deployment of the infrastructure, where it's actually heading to. And like I said, it's based on reactive microservices. So basically the main idea in reactive microservices compared to other microservice architectures is that it's responsive, it's resilient, and it's asynchronous. It uses asynchronous messaging, and it's also elastic. So basically it's message driven, etc. So that's why we use the PubSub. So each of those services that we have deployed are basically responsible of their own data. So they don't know other service data, and other service don't know their data. They cannot even access it if we so want. And then they communicate by the PubSub mechanism, so publish and subscribe kind of a way. And they all are self-scaling. So basically as we run in Kubernetes, it's just a replication controller, auto-scalable replication controller that can take over and scale whenever this particular service is now on high demand, so I'll give you more resources, etc. And also the Q project handles security in a way, so normally or don't ever put any security related stuff like keys or passwords or anything to your Docker images. No matter where you're going to host those Docker images, just to be sure, don't put them inside that Docker image. So in Kubernetes, we have things called secrets and config maps. So this Q project also automatically maps all your sensitive materials and sensitive configs and all the config itself to these Kubernetes resources. So you don't have to worry about it. Simple deployments, again, should be easy, both automated and manual. And now the project breakdown. So like I said, the e-commerce runs on project X. But this mobile endpoint actually, a mobile backend actually uses multiple other projects also. The reason is both isolation and data management. So here we can see that the cluster itself actually runs on project X. Shared resources, the NAT gateway, logging, monitoring, IAM, all of these are still in the project X. But then we have project Y, project Z, and then we actually EZ, D, there's a lot more where those came from. But mainly one of those, we have staging and production, an example here. So the staging has the PubSub interfaces, because this PubSub, data store, Bigtable, all of these are project-related resources. So this gives you the isolation of these different environments, like your staging, production, testing, etc. And also when using this PubSub, this is one interesting thing that comes towards you when you start working with these kind of things, is that when developers, many developers working together with the same backend, they start to suck each other's PubSub messages. And that's especially annoying if you're trying to debug something and someone else is doing something else and your machine starts getting the other messages, and it can get messy. So that's why this project isolation also helps you to cope with that. So, like I said, microservices are transparent to the developers in our cases, usually, so they don't have to worry about them. And also what I liked is about working with containers, and especially with Kubernetes, is that we can hide away the infrastructure, we can hide away the complexity of that and concentrate on the development itself. The only thing the developers need to know how much resources do they have in use. An example we use in Kubernetes namespaces for isolating completely our staging, production, testing environments. And on those namespaces, we have quota limits and these kind of resource limits. So the staging, in example, as they are running in the same physical cluster, so the staging environment cannot eat too much resources from the production parts. So these limits that you can allow and decide yourself really help. And then you just tell your developers, like, do whatever you want, you have this much resources in your disposal. And then this is just one single example of how the deployment can be done manually. So you just call this utility function, say deploy, you want to deploy to staging environment, and you want to update this kind of a auth service, which handles only the authentication pieces of your system. Basically the root API/API/auth. And the mobile clients either call that or something else calls that, etc. Simple DevOps. This is something that I've been really happy about because I really don't like working in the server end. I like to do these kind of infrastructure. I like to actually concentrate on what my job is. And currently we don't have enough DevOps people to run on every single project. But after moving to these kind of architectures that we use container engine and we utilize these managed services, etc. These days, usually I can manage most of our projects, basically all of our projects, with one single day a week. So what I do on that week, I run a single script that just checks whether all the Kubernetes nodes are up to date, which is just one command to gcloud utility. If they are not, I'll see whether I can actually update it or not, and or if it makes sense to update. And then our CI takes care of the static security analysis. We have this Claire, basically, that's running on Kubernetes, and also we run it manually. But this takes sure that it statically checks each container that we are running, so that there are no new vulnerabilities known. So this is especially important when you deploy your infrastructures as in containers. You usually just think, okay, now it's there, it's in production, I don't have to worry about it anymore. But then these security vulnerabilities, especially if you're exposing something to outwards, and let's say you use Python and you use some libxml or some kind of these kind of libraries that may have vulnerabilities and have known to have vulnerabilities. How are you going to make yourself aware that that particular client and that particular project had that container that actually included this and this particular version of that libxml, which is now vulnerable to this and this kind of attack? So these kind of tools you really need to make ease of your mind. And to remember, containers aren't really like self-updating. You actually have to make sure that they know what they are doing, and they should be pretty much stateless. And then for the Node.js projects, there are a couple of options like this Node Security IO that offers this kind of free tool for you to check all your module dependencies, etc. Whenever they have known vulnerabilities, etc. Few words, I should have actually included these slides even earlier. I just did them on the plane, but how many of you actually use Kubernetes? Good, so I thought I should have started from this one until talking all about that. So, few words about Kubernetes. So, Kubernetes, open source project started by Google a couple of years back. Google has been working on containers longer than a decade, and basically everything that they run these days is run on containers. The whole idea of the data centers is just available resources, and they run containers on them. Even the GCEs, so the Google Compute Engines that you run as virtual machines, are running on container in Google Cloud Platform data center. So they know something about containerization. And this project, Kubernetes, is actually the next gen, the open source version of their internal tool called Borg, which is now actually changed to something else. But yeah, it was the Borg. And there's a really nice read. If you want, you can find the white paper of that system, how it works. It's really high scale container running. But yeah, so they started thinking that maybe we should actually give this to free world. They open sourced Kubernetes, and now a lot of other companies are also involved with this. You can run Kubernetes pretty much on any cloud provider, and it's really getting powerful and more useful. And now even the Kubernetes, as they like to call it, that you can run a multi-vendor cloud. So you can run your Kubernetes cluster on top of GCP, Azure, AWS, etc. And you still see as a one single point of resources. And then you can just keep deploying your app and it'll go to some of these hosted services. So it's getting better and better all the time. And it's written in Go. And the main idea is manage application, not machine. So take away the infrastructure idea. Few components, key components in Kubernetes environment are pods. Pods are basically your ephemeral units of containers, amount of containers that you want to have. So let's say you have a Docker container that has a Nginx service, and then you bind that to a pod, give it a name, few metadata, all these labels, as we're gonna say, and then you're gonna do a service which actually exposes that pod to the external world or internal world with a static IP address. And you will use this replication controller to actually say that I want to always have at least one, or I want to always have at least two of my Nginx pods running. So the replication controller is the scheduler that runs behind the scenes and makes sure that you always have the demanded resources to run your application securely and safely as you've designed it. And these labels are the only means of grouping these pods together, or services and replication controllers, etc. There are, of course, other components also, like I said, secrets, which basically enables you to have all your sensitive information hidden away. And then by request, if the developer has access to that request, he can define in his pod specification that I want to use that secret with my pod. I want to expose it as either environment variable, or I want to expose it as a file in the file system. So then the Kubernetes checks whether that developer has access or that resources have access to that secret, and then mounts it to a read-only tempfs, etc., or to the environment. But yeah, so with labels, you say that I have version 1, version 2 of this pod, and then you can say to service that forward all the incoming traffic to version 1, and then you can say change it to say that forward all traffic to version 2. And also Kubernetes supports rolling updates out of the box. So you can just say when you do an update to your backend, the rolling update does it so that it'll first set up a new one new pod for you, and then it'll shut down one of the old ones and keep doing this until you have no more old one left and everything, all the new ones are up and running. And it directs this traffic piece by piece while doing that. So, quick recap of what have we learned of building these kind of infrastructures and these kind of systems is that monitoring and making sense of what happens inside your system is the crucial part. So I cannot enforce enough that make familiar yourself with tools that are best suited to your applications, but still the cloud monitoring tool, or the Stackdriver monitoring and Stackdriver trace tools, centralized logging in Google Cloud Platform, these have been a savior for us, so we don't need to have reinventing the wheel all the time, etc. We can have everything baked in there, and we have single point of access to that. So that takes some time. And with this particular case, full end-to-end testing has proven to be one huge pain in the ass. As you can imagine, when you are talking about physical stations somewhere around the country, so how do you actually test that when you click this button in your mobile application, something happens in there, wherever it is? So this has been a hard journey, and also could be a talk of its own, of how to deal with those kind of restrictions. And then, especially with the security, when you want your users, when you want your developers and your client to access only piece of information, those security abstractions, security rules, and IAM roles can get really complex. So that is something that you want to start planning early on, or what you want to do, what you want your developers to be allowed to do, etc. And take a quick look of what is possible now, and what is maybe possible later, and what's not possible at all currently, and then react accordingly. And also with the HTTPS load balancing, and we use the cloud trace with Node.js, I had to patch the Google's cloud trace module to actually support this kind of architecture that we did. But it's now patched, and it should be upstream already on that. But there was basically a period of time when we didn't get any traces to our system, and we were wondering, like, why doesn't anything get shown? And even though our logs show that every single thing is sent to that trace API for rendering, but yeah, there was quite a nasty thing happened, or update happened on the HTTPS load balancer service that actually prohibited this from working on. And how much time actually am I over time? Or okay. If you are still interested, I can take a quick look of how to do automated content analysis on real-time and archive data, if that's on any interest. Yes. Great, thank you. You're still feeling okay. So this case is also one of our newest cases, but something that we've been brewing quite a while. The past months I've been really keen on machine learning and all of these and doing all these kind of things. But now we got a really nice problem in our hands that we are solving for our clients, is that they have massive amounts of data. I talk about, like, since the 1930s, kind of a amount of videos, audios, pictures, these kind of things that they have no idea of what they are about. So massive data sets that date back to ages, and there's no use for them right now. They absolutely know how to utilize that, how to make it work for them, or how to make the public known about that content. And there's multiple use cases that I'm not liberty to say most likely, but I'm not going to go to how actually this works, but I'm going to show the architecture of how we did this on Google Cloud Platform. So this infrastructure in particular is completely serverless, fully managed infrastructure, so we don't have to worry about anything, which is really cool. I like that in infrastructures. What we do is that we do audio and video analysis and also static image analysis at the same time. So whenever we get data coming to Google Cloud Storage, we use object change notifications to trigger these cloud functions. Or let me just say that we have a virtual machine running that has these hooks deployed, because Cloud Functions is not read public. So object lifecycle management we use on GCS to manage the, okay, this has been already done. So basically this data has been managed, analyzed, so let's move it to more cheaper, the cold storage, even the new GCS storage level that they just announced a while ago. Then what we do for the audio, we create a transcript for whatever language that audio might be. We have a transcript for it, and for the transcript we do sentiment analysis and context analysis. So what was the text about? Who were basically, what was the context of it? And then we do a lot of this kind of, is it a positive, negative? And also we collect a lot of other through tokenization. So we connect adjective, verb, pairs, etc. to find key points of interest in that data. And then we use PubSub and Firebase to activate external services that are hooked to this automated content analysis. And with that, in example, we have a system that can take in or notify people that are that have some certain interest. We can notify them automatically through different channels of whenever there's a new content that matches their interest, or there's a podcast somewhere, or there's a radio stream somewhere, or there's a TV, basically program going on, we can actually utilize this for real time also. Not that exactly the same architecture, but we use it for real time, a bit different means, but still we get the same results. So this is how it looks. So all of these are just plain old available APIs that there's currently in the Google Cloud Platform. So we didn't really have to code that much of anything. So we use the Vision API for doing the image analysis or static image analysis. We use Speech API to understand the audio. We use Translate API to actually get a sense of the text. In example, most of our content for one particular case is in Finnish. So all the natural language API currently supports only English. So we use the Translate API to give all the data to that, get the English version, and then run it through. I must say, of course, the quality is not 100%. How could it be? But it doesn't really matter because we get enough information, and that's the key point. Because previously, we didn't know anything. Now we know main parts of what that audio or video was about. Main points of interest in that context. There might be someone speaking about a particular person or a particular place, location. Now we have that information and we can utilize that even more. Thanks to just these really available APIs that is on a GCP. But then this new one that they finally opened, we also have some custom models that we are running on the machine learning APIs. In example, one fun use case, I did an experiment of, we have this soap opera also in Finland, kind of a bold and beautiful kind of moment. I think every country has their own, this kind of a TV series. But we had also one of that, and I just wanted to see if I can catch certain actors, like which actors are currently on the screen. So I took the Inception version 3 model from TensorFlow, the paper, and the base model that Google gives you when you read through the TensorFlow papers, materials, and I retrained it with the faces of this TV series characters, and what did I get is actually pretty astonishing results. So now I can give it the feed of video, and we can get like this and this character is on this scene, etc. So it's pretty amazing with a few days of work in a sense. So these are really powerful tools that you shouldn't overlook at. And you can get really far away with just like filling with the APIs. And here, as I said, we store all the analytic data that we collect currently to also data store, and then we pipeline with data flow, etc. to BigQuery. And again, we have the centralized logging, which makes sure that we know what's happening inside the system. And then we use the tracing to see which of these actual analytic parts takes the most of the time, etc. And we can immediately see if something's going on or something's taking longer, then most likely there's something wrong with the language recognition or these kind of services that have been coded there. But this is has been a really nice and interesting project to build on, and definitely we'll be doing more and more of these kind of things. But just to give you a look of what you can already do with minimum effort and get forward. And then of course going forward from this, you could start teaching your own speech API model. You could start teaching your own image inception models, etc. And but yeah, that's one way to go to enforce that learning and make it more clever. That's it for me today. Hopefully it had at least some context to anything. I know I used to say that mobile backends, but I got so carried away about all that stuff. You can do a one-day talk about cloud endpoints. You can do a one-day talk about how to build those kind of infrastructures by hand, going live tutorials, etc. But hopefully this had been some of use at least. Questions?
Yeah. Hi. Great speech, by the way. Thank you. We have a really similar setup like you. We use the Google Cloud, we use Kubernetes, we use Node.js for the backends. We do struggle with one thing though, is the tracing. You mentioned that you use tracing on Google Cloud Platform.
Yep.
So you use StackDriver or what?
Yes.
And how do you implement it?
Yeah, so the ESPED, Google has actually an NPM module called Cloud Trace that you can use. And that's really simple. It automatically, if you include that into your project, it'll inject itself to Express, gRPC, all of these. But there's the catch, like I said, I had to patch it to actually work on the most recent version when you use multiple projects and together with HTML. But it works really brilliantly.
Okay, so I don't know how we managed to overlook it, so, but thank you.
Yeah, no problem.
Any other question? Somebody?
Everybody's so tired already.
Hi, I would like to ask how you see the future if you compare the containers and functions. If you think like the functions will overtake the cloud compute.
No, I don't think, at least not in the foreseeable future, because with functions you still have a couple of issues that we need to tackle on. One of the most is the pre-warming that I see as one of the most key points. Basically, as function, you don't really have any resources reserved to handle your API call whenever that comes in. And especially when you have time constraints or you want to build systems that are resilient, etc., and they respond in timely manner, then you wouldn't really want to use cloud functions necessarily.
And have you do any testing compared to the AWS Lambda? Because this is a pre-warming.
No, I haven't personally. I haven't done testing per se yet because I'm waiting for the cloud functions to come out of alpha, so then we can actually write blog posts, etc., share that information that we have. So, but yeah.
Thank you.
Any other question? Okay.
I didn't catch, and maybe you didn't see it, in your first case study. How does the mobile backend communicate with the ECOMMERCE?
Yeah.
Block?
So we basically use the HTTPS load balancer as just a way to distribute the traffic to our Kubernetes cluster, and each of those services that we have running there expose a ingress role through Kubernetes that then gets mapped to this kind of a URL map. Let's say we have a service that does this authentication. It exposes /API/auth, and we use RESTful for access, REST APIs basically to access those. We are also, of course, we've been investigating for the past year already about the gRPC possibility, now that the Google Cloud endpoint support it. But unfortunately, as we use Swift, mainly in our iOS development code, the gRPC library or the client doesn't really well compile yet with Swift if you have other pod files, etc. in your projects. So, but yeah, REST APIs mainly.
Any other question? Don't tell me you're not interested in content analysis. I can imagine so many applications of it.
Hi, I just want to ask about the content analysis. How was it related to the first project? What did you use it for? Or was it just a pet project for this soap opera? Or
Oh, you mean the relation between these two?
yeah.
Absolutely nothing.
Okay.
No, this one just came out as a simple example of, I just wanted to do something with the APIs, show a proof of concept of what can we do with these existing APIs. And then it evolved to something pretty nice.
Last question.
But that's something that happens when you don't have to worry about your infrastructure. You have more time to concentrate on the application itself. So,
So thank you very much, Jerry.
thank you.
Great presentation.